Grade 11, hello again guys, hope you are doing well. So still we are in chapter 11, chapter 20, section 3. Today we will explain what the meaning of the transformer. Guys, as you know, the electricity in our homes, it's between 220 volt to 240 volt. So 220 volt, sometimes 225 volt, and the maximum 240 volt. But usually it's stable and it's equal to 220 volt. Now, not all the devices work on 220 volt. Some devices, or actually most of the devices, need less than 220 volt. For example, now I need to charge my phone. For example, the iPhone need only 5 volt, but the electricity is equal to 220 volt. So we have transformer. Transformer is a device which can increase or decrease the electromotive force, the voltage. So we have step up transformer and we have step down transformer. Step down transformer, that's mean if the output is equal to 220 volt, so the output must be less than 220 volt. Step up the transformer, that's mean if the input equal to 220 volt, the output must be more than 220 volt. So transformer is a device that increases or decreases the electromotive of the alternating current. The relationship between the input and output electromotive force given by the transformer equation, delta V2 equal to N2 divided by N1 times delta V1. So, for example, guys, here we have a transformer. For the transformer, we have two-sided. So we have here the first two sides, the first side and the second side. All the time here the input. So for example, now I'm trying to charge my iPhone. So I will put the plug inside the socket. So here the input, the 220 volt, here the output to my iPhone. So here the input 220 volt from the electricity. Here the output, it's only 5 volt for my iPhone, for example. All the time the input has number 1. So for example, the input voltage, it's delta V1. The input current, I1. The number of the turns here, it's N1. Now, in the output, all the time has number 2. So the output voltage, delta V2, the output current, I2, the number of the turns in the secondary file, it's N2. So we have here primary file for the input and we have secondary file for the output. So again, the equation delta V2, that's mean the output voltage is equal to N2 number of the turns in the output file divided by N number of the turns in the input file or input coil times delta V1, the voltage in the input file or side or coil. I prefer to write the equation in a different type, so we can write it like here. So we can write the equation here. V1 divided by V2 must be equal to N1 divided by N2. I think it's better. So V1 divided by V2, it's equal to N1 divided by N2. So the primary voltage divided by the secondary voltage must be equal to the primary number of the turns divided by the number of the turns in the secondary file or coil. So here we have video. Let's see the video.
Transformer takes an alternating current as an input and produces an alternating current at a different potential difference as an output. In its simplest form, the transformer consists of an iron core wrapped with two separate windings of wire. One, referred to as the primary,
So here the primary input and here the secondary coil, the output. So because we have delta V1 as a because we have a delta V1 as an input, as we said, so we will get delta V2 because here changing in the current, because it's a AC current, so changing in the alternating current will produce I2 output current. Now, real transformer have efficiencies ranging from 90 to 99, but it's impossible to have a transformer with efficiency equal to 100%. Why? Now, the transformer equation assumes that no power is lost. It assumes that no power is lost, but actually it's impossible because we have some power lost inside the coil or as a heat inside the core, the iron coil. Now last example, inside the car we have step-up transformer inside the ignition system. So the battery for the cars has only 12 volt, but to use the spark plug it needs more than 12 volt. Because of that, here we have step-up transformer. So here the input to the transformer to the primary coil, it's equal to 12 volt. The output from the primary coil is gonna be more than 12 volts. And here we have the spark plug to the inside the engine. So here we have an example, a step-up transformer used in something across the primary. So here we have the primary voltage equal to 12. So potential difference across the primary is equal to 12 volt. So first given we have V1 equal to 12. Why V1? Because it's primary, so it must be V1. And the potential difference across the secondary of 2 times 10 to the power 4 volt. So V1 equal to 12 and V2 equal to 2 times 10 to the power 4. That's mean 20,000 volts. If the number of the turns in the primary is equal to 21 primary, so number of turns in primary, that's mean N1 equal to 21. What is the number of turns in the secondary file or secondary coil? So we have here the given, we have delta V1 equal to 12, V2 equal 2 times 10 to the power 4, we have N1 21, so find N2. So easy, we can use the formula here, N2 equal to N1 times delta V1 divided by N1 and find the answer. Or we can write it here, so we can solve it like we have V1, here the given V1 12, V2 20,000, which is 2 times 10 to the power 4, the same, N1 21, find N2. So V1 divided by V2 equal to N1 divided by N2, V1 12 divided by V2, 2 times 10 to the power 4 or 20,000 equal N1 21 into unknown, so N2 equal to 35,000 or 3.5 times 10 to the power 4 is the same. So the answer here 3.5 times 10 to the power 4 turns. Guys, here you have a homework, please try to solve it, and if you have a question we can discuss it in the live session. Good luck, see you next session inshallah.